Hello, everyone, and welcome to SPE Live. I'm your host, David Gibson, and thank you so much for joining us on this SPE Tech Talk with CGG. All right, it's no secret that the oil and gas companies produce an incredible amount of data, especially in the areas of production, operations, and accounting. An operation can save valuable time and money using technology and comprehensive taxonomy to organize and curate data. Yes, curate data. We're joined today by a pair of experts from CGG to discuss insights from their digital transformation journey. They will share their experiences of building and growing a diverse technology team. All right, like I said, we are live today, right? Just like every other day, but it's special every time we go live because we want to be able to interact with you, the audience. So like, share, subscribe, do all the little social media things that help us be able to get these wonderful messages out to people just like yourself. Speaking of which, if you would tag one of your friends in the comment section now, just because, I mean, if you're here watching, it's worthwhile to be able to share it with a friend. They'll get a notification, come over and join the stream now, or be able to watch it a little bit later. Another great way to be able to interact with today's broadcast, let us know where you're watching from. We would be more than happy to be able to give you a shout out here on the screen as we go through today's episode, as well as if you have any questions for today's experts, not me, the experts, right? Type it into the comment section now for a chance one of our guests will be answering it during our live Q&A segment. All right. So before we get started today, let's take a look at today's poll question. How much time do you spend on average, or how much time do you spend on average spending and preparing the data you need for your job? Is it A, 10 to 20%, B, 30 to 40%, or C, 50 to 60%? I will have to say D, 100% of the time, because I'm just not organized. All right, let us know your answer, and we'll take a look at the results later in the show. So please put your answer into the comment section now. All right, let's get started. Introduce today's guest. First, joining us is Tom Hewitt, head of Data Hub for CGG. Tom and his team provide digital transformation and expert data curation services and technology. He began his career as a geologist with a strong interest in technology. Tom eventually led the digital transformation of CGG's extensive geological multi-client library to create GeoVerse, the industry-leading subsurface data model and taxonomy. Our second guest today is Meghan Davies, operations head of Data Hub with CGG. Meghan assisted in the setup of Data Hub and currently works alongside subject matter experts, data scientists, and software engineers to solve their clients' digital transformation challenges. So she joined CGG 9 years ago as a graduate geoscientist focusing on frontier exploration. Hello, Tom and Meghan, and welcome to today's SPE Tech Talk.
Hey, David.
Hi there. Nice to be here. Thank you.
All right. Well, let's get started by walking our audience through some of the graphics you've prepared that detail the transformation from trapped data to streamlined digital workflow.
Perfect. Yeah, if we could pull up the first image, that'd be great. Yeah, so this kind of illustrates what we mean when we say trapped data, right? So this is pretty familiar to people in industry. Very large documents containing complex technical information. Example on the left is some PVT, pressure, volume, temperature data. This is used to really understand fluid behavior and later on downstream is to simulate the flow and extraction from a reservoir. This particular document will have about 70 pages. It might have 100, it might have 50. And you can see quite a complicated table inside it with all of the technical information that the geoscientists will want to utilize, right? On the right, we can see a core image. There's likely to be, again, hundreds of these per asset. And this is really used to kind of ground truth the real rock in the reservoir and model the physical reservoir properties. And we've tried to put an indication of the sort of relative cost of these things, right? So incrementally generating this type of PVT data has a cost. Incrementally generating core, cutting core, and generating these images has a much bigger cost. So that's the nature of the data. If we can go to the next slide, this is then kind of zooming out on the problem, right? So those are two examples. They're in this slide. You can see lots of other complex technical information. And we've got stratigraphy there. We've got drilling parameters. We've got mercury injection capillary pressure used to get really accurate measurements of the porosity permeability. We can also see something called core tomography, which is actually taking a CT scan of the core to look at the internal structure of the core. And the point of this is to say that the data in the industry is very, very diverse. It's very complex. One size fits all solutions don't really work on it, and it has a lot of value. So if we zoom out again to the next slide, when we look at a whole asset, when we look at a whole basin or a region of the world, you've got really huge volumes of this type of data. You've already seen the variability of that. It varies in terms of formats and layouts, vintages. And a big problem in the industry now is the loss of experience, right? So we're losing people, we're losing experience, and we're also losing knowledge of what this stuff means and where it's stored. And really, operators and users of the data are trying to do more with less. And they want to integrate and share the data. And eventually people want to apply data science and machine learning to actually predict things on top of this data. And when we look at a whole asset, we might have millions of files, right? Millions of similar files with hundreds of pages per file. So it's not really a manually solvable problem. So if you move to the next slide, this kind of outlines what we do to try and solve this problem, right? So this is the Data Hub workflow. And there's a bit of information on here. I'll start with the middle kind of bar, right? So we run this workflow, which we divide into classification, extraction, enrichment, and finally visualization. And at the top there are some examples of those results. So first thing we do is we ingest all the data into this big data pipeline. We generate a graph. This graph represents the content of all of those files. So that PVT table, that core image, will be represented in that graph. Then we extract from that graph the data objects, and we use a series of different machine learning and traditional techniques to extract that. We then warehouse all that data into a big data system, and we also run enrichment. Enrichment will look like the example on screen is another core image, and we're actually using the core image to predict the lithologies, to predict the rock types directly from the image using calibration and experts. So that's adding a data series that wasn't in the original. And finally, you've got visualization, right? And we end up at this point where we've got a beautiful dashboard of lovely data. At the bottom there are a series of technologies. I'm not going to go through those, but we use a bunch of cutting edge technologies and open source. And in the middle, most importantly, is the involvement of experts. And I'm kind of going to hand to Meg for a moment to talk about the role of those experts in the workflow.
Sure. So our integrated team is really one of our key tools. We have geologists and petroleum engineers, our subject matter experts, that work alongside software engineers, machine learning engineers, data engineers, and cloud architects. And this really allows us to learn most from each other, but also allows us to best tackle this digital transformation problem that we're dealing with. And all of our team members work really closely together. But everyone also really works with the customer as well. So we have teams working with the customer to transform their data in workshops. And then we have counterparts working on the other side on deployment and delivery. So absolutely everyone is involved. And what we really try to instill within our team to be able to do this is a sort of culture of ownership. And I think the problem we're trying to solve really lends to that as well. I think everyone has probably been in a situation where you're trying to find that really key bit of data and you just can't, whether you're at university and you're trawling through papers, just trying to find it, or when you're at work in your career and you're clicking through folders, someone said, oh, there's this really key file that has that data, you need to be able to make that decision. And you're just clicking and clicking and going through and through, and you just, are really struggling to find it. So that's, the problem that we're trying to help solve here. And I think all of us in the team, having had firsthand experience of going through that ourselves, we know how we want to make it better, where we can have that impact. And I think everyone in the team really has something valuable to contribute to this, whether it's a piece of code or an understanding of carbonates as well.
Yeah, there's no better way to be able to solve a problem than having had the problem yourself initially. So, Tom, give us some background on the development of this technology. In other words, how did you get to where you are today?
Yeah, so we had a very long-term library of products, right, in the company. Meg knows the story because she helped build a bunch of these products, right? So we're talking about 50, 60 years worth of product, right? And these are in a variety of different formats, like the ones we've seen, but also kind of really custom, strange formats. And so we decided back in 2016 to try and digitalize all of this data into one big data system. This really developed our data model. This gave us our initial seed point of a place to store all the parameters that we find in the subsurface, this big data model. And having gone through that, we also developed a bunch of technologies to pick up those files and pick up that data and migrate it into that big data system. And this ended up as a product called GeoVerse, as it happens. It's not super important to the story, which now contains all of those multi-client products. But it really gave us that problem to solve, and it led to this focus on what we kind of call top-down data, right? So rather than just worrying about bottom-up, storing all the files and representing all the files in a system of record, we're talking about a top-down solution to a geoscience problem. So it really focused completely on trying to solve that subsurface challenge.
Well, oh, I didn't know if Meghan was going to jump in there. Okay, Meghan, is taxonomy?
I was going to say.
Yeah, go ahead.
Tom mentioned the red books there, and it used to be when you were producing them, I was like one of the ones working on it. It was kind of seen that the bigger it was, the better. So that was just us generating more and more and more that was there, and it was just becoming a challenge for people to find what was really key in there. So that's sort of part of the problem as well.
So Meghan, is taxonomy continuously evolving? Is it exclusive to the oil and gas industry?
Okay, so our taxonomy is really a distillation of our subject matter experts' knowledge. So it's essentially their knowledge in geoscience and petroleum engineering brought into compute-friendly format. So it allows us to rerun their knowledge through our systems and machine learning. And we're continually refining, adapting, and adding to it. I think you would think maybe after sort of 50, 60 years of all this past information and data that we have, that we would have come across every term or data type. But I think we even surprise ourselves. We still come across things now that we're adding to that as well. And yes, we're actually expanding the taxonomy outside of just oil and gas into other industries. So naturally, we've done this with industries a little closer to home, so mining and minerals, geothermal, CCUS, but actually some non-industry topics as well, such as legal and procurement. And I think that's one of the really exciting things about the technology that we're developing, is that it can be applied to any industry, really.
Excellent. Well, thank you, Meghan. Let's take a moment to remind our viewers to get involved in today's discussion. Tell us what your biggest data frustrations are. Type in your comments or questions and hopes that on today's topic. And so hopefully during our live Q&A segment, our experts will answer your questions. Meghan, we'll direct this question to you first, and Tom, feel free to be able to jump in. Explain what your output looks like.
All right. So one of the on one of Tom's images at the start, you saw the visualizations, and the image there was of a dashboard. And these are user interfaces that we've created ourselves, which display the curated data connecting to the database behind it. And again, we like to take a really integrated approach in creating these. And actually, our lead UI developer who's creating these, he was actually a geologist by background, and he's just learned how to code and upskilled in that area. So he's designing these and creating them at the same time. And this has actually been a really great tool for us as well. We created a role called the data geoscientist, and this is where we're looking to attract wonderful, unique individuals who are geologists by background but love data and can write Python too. And Tom, did you have anything you wanted to chip in as well?
No, all I'll say on that is that particular that role we've created called data geoscientist is very deliberately formed, right? It really seems to appeal to a group of people who are transitioning from pure geology and geoscience subsurface topics through university, coming out of university into a different market, and then transitioning over to learning to code. And I think it's been a real success. We've added some fantastic people to the team, and it seems to be a very popular role. I mean, Meg is doing a lot of recruitment at the moment for us, and it's a huge job to keep on top of. But that particular combination of somebody who's got some subsurface experience and someone who's built up that coding skill set has worked so fantastically well. Of course, we complement them with pure machine learning engineers, mathematicians, physicists, software developers, cloud architecture, through to pure experts. So we do have to complement them with other kind of expert skill sets, but I think it's been a great success for us.
It's definitely a growing theme in the industry to be able to find somebody that has their technical expertise combine that with just enough coding to be able to understand that, and then, as you guys are saying, and wonderfully done, is matching them on either end with more technical experts or even better coding experts. So how does obviously y'all have laid out how your team works. How does your team guarantee a good result?
So we have a variety of different ways that we check this data. And back when we were doing this big transformation of those products I spoke about earlier, the GeoVerse program, a lot of our checks, a lot of our QCs were pretty manual. People were looking at the ranges of data stored in the system and performing statistics on it, kind of case by case basis. And what we've effectively done over the last 2 years is take all of the scientific rules that people apply to data. So that type of rule might be, we're seeing a high porosity from the CCA, from the conventional core analysis, which has been brought in through the system. And simultaneously, we're seeing that it's occurring in a mudstone, according to the machine learning model. And we can bring those two data sets together, cross-correlate them, and do quite a complex QC that's based around the science. So what we've now done is coded up thousands of these rules that perform this cross-correlation between different domains. And I think it's leading to spotting errors that we would never have otherwise spotted. We're spotting errors that occurred in the original capture of the data and finding those. In addition to that, of course, we've got experts just reviewing the data, doing the typical things that experts do, sense checking, looking at ranges. We've got statistics and outlier detection and other techniques that we apply, but those are the main ways that we guarantee a result, and that's all part of that expert message, right? That these are scientific expert algorithms that we're running to check it.
And these QCs, sorry, just to chip in.
It's y'all's show, not mine.
So our team are continually creating these and evolving these and writing these rules into the system. And when we run all this data through it, it flags up anything and the team can go and investigate that further. So it's really quite a robust method that we're building here as well.
Okay, so as a follow-up question to that, how do you ensure an easily integrated, standardized result?
This is quite a big question. So we have a data model. We have our own data model, right? So as a user, you can choose to use that data model. And we've entered into some big partnerships, which we've press released recently. And one of those customers is definitely initially using our data model as the vehicle to consume the data, right? So we provide the data model, we provide the user interfaces, and they just use them like a website, like an end user. However, people obviously want to go further and they want to access that data across the whole range of petrotechnical software, custom software, dashboard solutions, and so on. And there's a big initiative in the industry called OSDU going on, which there may have been SPE Tech Talks on. And that's really the coming together of all the operators, the service companies, the software vendors, the data providers to standardize the data model and standardize the connectivity around all these different applications. So what we're doing from a data perspective is quite clear. We're contributing our data model free of charge to the OSDU. We're providing developers to implement it. Piece by piece, right? It's a complicated thing. It's not all in one. And we're then building on top of that data model, helping OSDU to mature the APIs and the connectivity, and also modifying our user interfaces to connect. So at the end of this journey, we should be able to bring data in through our unique process, but output it in a very, very, very generic, standardized way that operators can just ingest into their OSDU, or we can do that for them.
Excellent. Megan, I won't interrupt this time. Do you have anything else to throw in there?
No, I don't this time, actually.
Well, thank you both for all the great information. Now let's take a look back at our poll question that we asked you. How much time do you spend on average finding and preparing the data you need for your job, right? So is it A, 10 to 20%, B, 30 to 40%, C, 50, 60%? And most of the answers came up 50 to 60%. What are y'all's thoughts on that? And does that feel like something that y'all could solve?
Well, yes, and it's not surprising, right? Because we're constantly talking to customers, and the number goes up to 90%, depending on how you measure it, right? I mean, if you take someone who's really, really good at interpreting subsurface data and understanding it, how much of their time can be spent doing that if the starting point is 20,000 PDF documents and spreadsheets? So obviously the answer is not a lot, because there's so much work to do before you get to that clean data set. So it's not really surprising at all. I think it's a huge problem. I think digital transformation is a big subject. There's a lot of different segments to digital transformation. There's a lot of different parts of that. Some of it's about ingesting dynamic data and standardizing that dynamic data. Some of it's about the initial scanning and OCR and capture of files and cloud migrations and other things, which are very big business. And we're really in one part of that, solving this niche science problem on this complex subsurface data. So I think it does really help. I think we see that consistently with working with our customers.
And as Tom
Excellent.
said, 50 to 60%, people say, we debated whether we were putting in a higher option as well, because as you said, people say up to 90%. And if you think of the teams of all these people in positions where they need to make crucial decisions quickly, especially with a sort of changing energy landscape as well that we're moving towards. If someone's able to have that data, make that decision much quicker, and they're actually spending their time on that, that's a much better use of time and money in that sense as well.
Excellent. Well, thank you both so much for answering all the questions today, and for those still watching and whatnot, feel free to be able to throw out your answer for the poll question even more. So now we do have a question that has come in from the audience. So audience, if you would like, please submit your questions to the comment section for us to be able to get it over to one of the experts. This question comes from Dimitri. What do you think about the confrontation between expert experience and machine learning based on big data? Machine learning is not always win.
It's actually a very good question. So there's a tendency for people to think humans give a 1.0 result in terms of a success or a quality score. There's a tendency that everybody thinks their result is right. But there's also a feeling that if you ask 5 geologists for an answer, you'll get 6 to 10 answers. So it can't be the case that people are 100% correct. So our general feeling on this is it's better to have a statistically verifiable 80% result on millions of pieces of data than it is to have a result which is seen as 100% accurate on 100 pieces of data. And so it really is, the big data point is the key point, right? The more data that you use, the more statistical you can be about the answer, the more you can trust the 80-90% machine learning result. Now, I said 80, but we can push that, right? The more accuracy we can give the models, the more training we can give the models, the more we can push the accuracy above 90, above 95%. But that's the kind of my general feeling on this question is yeah, people are not always right, and then the other side of it is the more expert input we have into those models, the more we can remove the 15 or 10% of the model result which is wrong. So by performing those science-based checks on the machine learning result, we can get rid of the bad result and end up with something that's very close to 100% accurate.
Yeah, I believe there was a TED talk about how they said it was machine learning versus the person, and both of them kind of failed short, but the combination of the two was like the paramount. So that seems to be like the sweet spot. So another question here. Do you think physics-based models are still better than machine learning? From LinkedIn user. So thank you, LinkedIn user.
It's a really good question. I think if there's a physics-based solution, then it's better than machine learning. If there's a physics-based solution that can actually resolve the full problem. But for some of the things we're talking about here, the extraction problems, classification problems, it's really not a physics problem. So there's no problem at all using machine learning to just scale up the amount of result that we get and be able to tap into that kind of 90% of lots of data rather than 100% of a small amount of data. But yeah, I mean, if there's a physics-based problem like seismic imaging, then the physics-based solution will probably generate a more high quality result.
All right, now we've got one more question here. This one comes from the SPE Energy Stream. So thanks for those watching on SPE Energy Stream. What percentage of your solution is software versus services from CGG? That's from Becky Thomas.
Yeah. So our software is a a journey, right? We've built the business logic, we've built the core machine learning models, we've built the orchestration system. We can run it at scale on a customer site. However, at the moment, we're running that on the customer site, right? We are kicking off those jobs. And the basic reason, to be totally open on the stream, is that all of the user interfaces required to run it yourself are not built yet. So having said that, that means basically we fundamentally offer a service built on top of technology. But having said that, as soon as those user interfaces are ready, we're very happy to hand that over to the customer to run themselves, at which point it will be a software solution.
All right. Well, we've got the audience asking lots of questions today. So another one here, this one's from Mohammed. Do you think if we rely on machines and computers will result in slowing down of brain development for future generations?
I can answer this one. I think it's quite interesting and a topic that I think comes up quite a lot. And personally, I don't think it will. I think I heard a statistic recently that was around like 90% of data has been generated sort of in the last few years. And it's just increasing and increasing. We're constantly generating and gathering new data. So I think the way that we're currently working or traditionally processing data or thinking about it, we wouldn't be able to handle it all ourselves. So what we're doing with machines or computers is taking out a lot of that manual work, and I think is freeing us up to actually use our brains to think about something in more detail, or something that will have more of an impact. We're spending the time on the right things now rather than things that take up too much of our time, is my personal feeling on it.
Excellent.
Did you have anything, Tom?
Totally agree. It's a perfect answer, Meg, in my opinion.
Thank you.
All right. Well, we appreciate both of you for joining us today on today's SPE Tech Talk on tools for digital transformation. If anybody's interested in learning more, what's the best way to be able to get in contact with y'all?
LinkedIn,
yeah.
Email. I'll also be at the Energy and Data Conference in Austin coming up 15th, 16th of November. So I'm quite happy to talk to anyone at that conference. It's quite relevant to this subject.
I had no idea there was an energy and data conference right here in Austin. Okay, well,
there it is, right there in Austin.
That. All right. Well, thanks again, Tom and Megan, for joining us, and thanks to CGG for letting y'all take some time out of your day to be able to talk with us. Watch a replay of this episode on the SPE Energy Stream, the industry's digital pulse. Visit streaming.spe.org. I've been your host, David Gibson. Join us next time right here on SPE Tech Talks. And as I always say, know your industry.
The energy industry is evolving rapidly. To stay informed, you need relevant content available when and where it's convenient for you. Introducing the SPE Energy Stream, the energy sector's platform for quality content from around the world. Energy Stream gives you access to technical solutions, innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event presentations, this easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders, then save the videos that interest you so you can watch them at your convenience. Stay ahead of the curve. Start watching SPE Energy Stream today.